Okay, in this problem, we want to solve the initial value problem. Here's our differential equation, y double prime minus 5y prime plus 4y equals 0. And here are our initial conditions. So first take a look. This is a second order linear homogeneous differential equation with constant coefficients. And so the way we're going to solve this is we're going to first find the characteristic equation, which we can just read off the coefficients. R squared minus 5 times r plus 4 is equal to 0. Then we want to solve for r, so in this case I can factor how to get r minus 4 times r minus 1 is equal to 0, and so r is equal to 1 and 4. We got two distinct roots, which means that our general solution will be y of x is equal to a constant times the first exponential, e to the 1 times x, the first root, plus a constant times the second exponential, e to the 4 times x. And that's our general solution. And now we want to use our initial conditions to find the particular solution to this initial value problem. So with y of 0 equals 2, if we plug in 0 into y of x, you can see this will become 1, or exponentials will become 1. And so I'll get on the left-hand side c1 plus c2, and that's equal to 2. And now the second condition requires the derivative of y, so we have to take the derivative of our general solution. And we can do this using, well, the first one is just a constant times the exponential, which just stays the same. And the second one, we have to use the chain rule, so we get 4c2 e to the 4 times x. And now we get y prime of 0 is negative 3. Again, if I plug in 0 in for x here, I get these exponentials become 1. And so what I end up with is c1 plus 4 times c2 is equal to negative 3. And so now you can see I have two equations with two unknowns, so I can solve for both c1 and c2. So I'll use substitution. I'll take the first equation and I'll solve it for c2. c2 is 2 minus c sub 1. And then I'm going to go ahead and plug that into the second equation. So I'm going to, for c2, I plug in 2 minus c sub 1. And now I just have an equation in c sub 1. So I'm going to go ahead and solve. So I get, if I expand the left-hand side, I get 8 minus 3 c sub 1 is negative 3. So I get, let's see, negative 11. And so c sub 1 is negative 11 divided by negative 3, or 11 over 3. And now I can go ahead and plug this back into my other equation. And so I get c2 is 2 minus c sub 1, which is 11 over 3. And if you add those, subtract those, you get negative 5 over 3. And so there you go. Those are your two constants. And so now we go back to our original general solution right here. And we can go ahead and plug in our constants to get the final answer. So we get y of x is equal to c sub 1, which is 11 over 3 times the exponential, minus 5 over 3, the second constant, times the other exponential. And this is your final answer.